Alright, hello, this is 10.1 Parabolas. Hopefully you guys have this sheet of paper already out and you could just take notes on it. So we're going to be doing conic sections, and conic sections are exactly that. They're sections of a cone. So basically if you were to take some sort of a blade or a knife and you were to have like a block of cheese that's in a cone shape and you were to slice it at an angle, this would produce a parabola shape. And then if you were to go straight down, up and down, this would produce a parabola up here and a parabola down here. That's called a hyperbola. And then if you were to slice it diagonally this way, it would the cross section there would be an ellipse. And then if it was to be exactly parallel with the bottom and the top, that would be a circle. So hopefully you guys have this, and we're going to do some notes directly on this. And here we go. All right, so 10.1. We are going to classify conics first, being able to tell the difference, and then kind of advanced is going to be identifying the focus and the directrix and right equations of parabolas. Alright, so why PHEC? Well, PHEC comes from the four different shapes that we get from these conic sections. The first one, obviously, like I've said before, is a parabola. And then the next one is a hyperbola, so PH. And then we have an ellipse, and then we have a C for circle. So parabola, hyperbola, ellipse, circle, PHEC. So later on when we take a PHECing quiz, it's going to be how you tell the difference between all these different shapes. So like I said earlier, hyperbola is going to be a cross section where it cuts the top cone and the bottom cone, and ellipse is going to be a diagonal, a cross section, and the circle is going to be exactly parallel with the base. Okay, so something that we know about a parabola when we look at its equation, what makes it different from all of the different ones, is basically it has one squared variable. Okay, so one squared variable, whenever you see an equation that has one squared variable, you know that it's going to be a quadratic or parabola. And then over here, when it comes to a hyperbola, an ellipse, and a circle, they will have two squared variables. All the rest of them will have two squared. So that's why first you check if it's a parabola. If it's a parabola, then that means that it's going to be one squared variable. So just stay in this PHECing order, and then I promise you will be able to tell the PHECing difference. So hyperbola, two squared variables. Something else about the two squared variables with the hyperbola, which is different from all the other ones, is that the two squared variables will have opposite signs. Okay, so all these other ones, they're going to have the same signs. So that means that right now an ellipse and a circle, they're identical. Okay, but what's different between an ellipse and a circle is that this one's going to have different coefficients, okay, or different denominators, which I'll explain later. And then these ones will have the same coefficients and the same denominators. So let's go over this. A parabola is going to have one squared variable. An hyperbola is going to have two squared variables, but so are all the other ones. Okay, and the difference between a hyperbola, an ellipse, and a circle is that they're going to have opposite signs. Okay, an ellipse and a circle will have the same signs, but an ellipse will have different coefficients. And again, a coefficient is going to be the number that's right next to the variable or a different denominator. So, with that being said, let's look at this real quick. What is this? Try to tell the PHECing difference. And again, I'm not cussing you guys. I'm just saying PHEC. What is the conic section that's being identified here with this equation? Like, look, it says I classify each conic section. So, is it a parabola? How can we tell if it's a parabola? Well, a parabola is going to have one squared variable. All right, so here we see that there's two squared variables, so we know that it's not going to be a parabola. All right, so if it does have two squared variables, it's got to be one of these three. And so we're going to look at the two squared variables. Do they have opposite signs? Because remember, the hyperbola is going to have opposite signs. So here, this is a positive x squared, this is a positive y squared, so that means it's not a hyperbola. So it's either got to be one of these. So remember, the coefficients are going to be the numbers in the front, and the denominators are obviously in the denominator or on the bottom. Okay, so here I see this is a coefficient of 1, this is a coefficient of 1. So that means it's not going to be an ellipse, it's got to be a circle. Everybody understand? So that is a circle. So see if you could look at this next one and see if you could tell what the PHEC it is. All right, so two squared variables. And if there's two squared variables, we know that it's not a parabola. Okay, so sometimes what I do, or at least I recommend, is that you just write down the word PHEC, and then you go through and cross each PHECing thing out as you go along. So it's not going to be parabola because there's two squared variables. The two squared variables are not opposite signs, so it's not going to be hyperbola. And an ellipse An ellipse is going to be different coefficients, which these are the same, so this has to be a circle. All right, how'd you do? Okay, so let's look at this one. A little bit different. So why don't you turn to your cat right now and ask him if it's a parabola? Yeah, not a parabola. Why not a parabola? Because a parabola is only going to have one squared variable, and I see the two variables that are in this equation are both squared, raised to the second power. So not a parabola. So let's see if this is going to be a hyperbola. Is this variable right here, it's a positive x squared, this is a positive y squared, so it's not hyperbola. So it's either got to be an ellipse or a circle. So if it were an ellipse, then it would have either the same coefficients, or I'm sorry, different coefficients and different denominators. And we see that they have different denominators, so that means this has got to be an ellipse. Does that make sense? Not too bad, right? Okay, so try this one. What do you think this is? All right, we see two variables, only one of them squared, so that's got to be a parabola. That makes sense? Okay, next one. Try this. All right, so we see a variable right here. We see a variable right here that's inside parentheses that's squared. So since this variable is squared, this one isn't, this would also have to be a parabola. I want to take a little side detour here and show you guys something. Normally, whenever we see parabolas, you know, back in the day when we did quadratics, it was y equals x squared. So the x is squared. Whenever the x is squared, we have a parabola that's opening up like this. Now, if we had y equals negative x squared, we remember that if the x or the squared term was negative, then it would be flipped around like this. So when we have the x, that's not the squared term. So check this out. So now we have x equals y squared. And instead of a parabola that's opening up like that, we're going to have a parabola that's opening off to the side. Okay, and then in the same likewise manner, if I have x equals negative y squared, then that's going to be a parabola that's opening to the left. Okay, so we can have a happy face, a sad face, or a C or backward C. Okay, so keep that in mind. All right, so let's look at number 6. What is this? What the feck is this? And again, you guys don't try to wrap me out. I am just saying the word feck. Okay, there is a fecking difference. So here we go. We got two squared variables, so we know if it's two squared variables, it's not going to be a parabola. We got two squared variables. It could be one of these. Now this is a positive, this whole term right here is a positive y squared. This is a negative x squared. So that means that they're opposite signs. So if they're opposite signs, then that means that it's a hyperbola. Okay, so this one's hyperbola. Let's try here. What do you think? Yeah, we got one squared variable, so that's going to be a parabola. So real quick question, let's see if you guys know. Is this going to be a happy face, sad face, or is this going to be a C or backward C parabola for this one right here? All right, so since it's y equals, that means it's going to be one of the blues. And then since this is positive, then that means it's going to be a happy face parabola going up. Okay, nice work. All right, last one here. Take a second, see if you can tell what the feck this is. All right, so we got two squared variables, so it's not going to be a parabola. Is it a hyperbola? Now, even though in here we have a negative, the x isn't negative, the 1 is negative. If the 1 is negative, that's fine, but the x is still positive. And over here, the y is positive. So then both of these variables are both positive, so it's not a hyperbola. Let's see now, is it going to be an ellipse or a circle? So we see over here, this has a denominator of 1, this has a denominator of 25. So since it has a denominator of 25, that means that they're different. So then it's got to be an ellipse. Does that make sense? You guys think you could tell the feckin' difference of these things? Great. Let's move on. All right, so now I'm going to do an overview of each of the 4 different conic sections just to kind of sum it up. And then I'm going to, for the enhanced part, I'm going to focus on just the parabola. And then the next couple of PowerPoints lessons we'll be talking about hyperbolas and then circles, or I'm sorry, ellipses and circles. So again, this is the parabola, and a parabola we know is going to have one squared variable. We have 2 different types. We have one where the y isn't squared and the x is squared. Remember, that's going to be a happy face or a sad face parabola. Okay, the components that you see here, this is a directrix, this is a line right here, and this is a focus. We'll be talking about that later. So notice that the focus is on the inside of the parabola. The directrix is a line that's on the back side of the parabola, okay, wherever it's opening up. So we know that if the y was the one that wasn't squared, we also have the variation where we have the x where it isn't squared and just the y variable is squared. So again, still it's only one squared variable. We know that this is going to be the c and the backward c. Notice that the directrix is on the back side, the focus is on the inside of the parabola. Focus on the inside, the directrix on the outside. Okay? All right, this is a function. This one is not a function. I don't know if you guys notice it doesn't pass the vertical line test. Vertical line test for these ones, it won't work out. Okay? All right, so focus and directrix, those are going to be really important, and how we're going to find that is we use this formula here where the A is going to be equal to the 1 over 4c, and c is the distance to the focus and the directrix. I'll talk about that more in a minute, but the A is the value that's in the front. Okay, so if you're taking notes on that paper, I would write all this stuff down, pause the video, and go ahead and jot those down. This will be good to reference. Okay, next we have our hyperbola. Hyperbola, again, is going to be two squared variables, but the only difference, I guess, is that we have opposite signs when it comes to the equation. So here's an example layout, kind of like when we have vertex form. We know that the h and the k with vertex form, we have to take the opposite when it's inside the parentheses. All right, so we have two different variations. Notice that this one, the x term is first, the y one is first. So these two first terms are the positive of the two. Notice that since this y is negative and over here the x is negative. So remember, it's opposite signs for the hyperbola. So the hyperbola, when the x is going to be the positive, it's going to be a sideways hyperbola where there's two parabolas opening up in the opposite direction. Okay, and then when the y is positive, then it's going to be a hyperbola where it's opening up in the y. So just, how I kind of remember it is if it's the x is positive, then it's on the x-axis, all right, or it's growing in the x direction, not necessarily always on the x-axis. And then if the y is positive, then it's growing in the y direction. Okay, so that's hyperbola. You can pause the video and then go ahead and jot down those notes real quick. Next, we have the ellipse. An ellipse, again, is two squared variables, just like hyperbola, but then the signs are going to be the same. But remember, a circle is also going to be the same signs, but the only difference is it's going to have a different coefficient or different denominator. So let's see here. Here's an example of an equation. Here's another example of an equation. The only difference, really, that we see is that we have an a underneath the x, and then down here, the b is now underneath the x. Okay, so over here they kind of swap. So what's the difference between these two equations? Well, this is how you can tell the different growth of the ellipse. So for this one right here, the a is always going to be the bigger of the two numbers. So if the two denominators are different, kind of like what we highlighted up here, if the denominators are different, if the bigger denominator is underneath the x, then it's going to be bigger in the horizontal direction. And then if the bigger number is underneath a y, then that's going to be a vertical ellipse. Okay, so bigger number under the x, horizontal ellipse, bigger number underneath the y, then it's going to be a vertical. So maybe the question is, well, what if they're the same? You know, if one's not bigger, well, that's when it's a circle. Okay, so on a circle, we know that it's going to have two squared variables, the same signs, but now it's going to be the same coefficients or denominators. So if the numbers are the same, then that means it's going to be going equally in the x direction and equally in the y direction, which is a radius that goes all the way around. So an example here, so since the denominator is both going to be 1, okay, or if we were to divide both sides by 16, they would both be 16, we would be going 4 over to the right and 4 up, and then it would create a perfect circle. Okay, so go ahead and pause the video. These are your basic real quick reference notes for this chapter. All right, so before we wrap up this first section, why don't we take a look at these 9 questions and see if you guys can tell what the PHEC it is. So I'll go through. Remember, we have the, come on, if I could write here. Oh yeah, PHEC. Tell what the PHEC each one of these is. So go ahead and pause the video, and then we'll go through and write these down. Okay, so the first one, it has two squared variables, so we know it's not going to be a parabola. It has two squared variables, but this one's a positive, this one's a positive, so that means it's not going to be a hyperbola. and then either it's going to be an ellipse or a circle. So we have two different coefficients. Different coefficients mean that it's going to be an ellipse. So this one's definitely going to be an ellipse. All right, hey, did you guys even look at this -6? Did you look at the equal sign? Did you look at the zero? See, all this other stuff is just going to be there, like it's just in the background, okay? You're looking at only the squared variables for each of these questions. So question number 17, we have two squared variables. It's not going to be a parabola, two squared variables, but they're opposite sign. This one's a negative, this one's a positive, so that's going to be a hyperbola. We have two squared variables again, so not a parabola, and then they're opposite signs, so that's going to be a hyperbola. And then here we have two squared variables. It doesn't matter if the coefficients are the same. You guys go in the fecking order, or else you're going to get these fecking wrong. All right? Does it have two squared variables? So it's not a parabola. Are they opposite signs? Opposite signs. So that means that this is a hyperbola as well. Next one, we have two squared variables. All right, that's good. So it's not it's not a parabola. It's not a hyperbola because the signs are both positive. So it's either got to be an ellipse or a circle. Since the coefficients are the same, that means that this is a circle. Okay, the next one right there, we have two squared variables, so it's not a parabola. And then we've got a 9 and a positive 16. So they're both positive, so that's not a hyperbola. But we have two different coefficients, so that's going to be an ellipse. Okay, so question number 22, we have two squared variables, so it's not going to be a parabola, but with these two squared variables, we have opposite signs, so that will be a hyperbola. Question number 23, we have two squared variables, not a parabola, but they're opposite signs, so that's a hyperbola. And then the last one, question number 24, we have two squared variables, not a parabola, and then they're not opposite signs, so it's not a hyperbola. It's either going to be an ellipse or a circle, and since the two coefficients are the same, that's going to be a circle. All right, so how'd you guys do? All right? Okay, great. So next is going to be strictly for Enhanced, Math 3 Enhanced. So if you're in Math 3 Enhanced, and you guys can check this out if you want. So basically, we see these conic shapes in our everyday life, like if you're driving down and you see one of these big smokestack things, okay, so we see the hyperbola right here, a hyperbola right here. We see how planets orbit in our solar system. That's an ellipse. We see a parabola when we shoot basketball, okay. So I'm going to look specifically at a parabola and go into some more detail. So every parabola will have this thing that's called a focus. Now we see this a lot whenever we, oops, I went too far. Whenever we, let's say if you have a flashlight is right here, and then there's a concave glass piece, because what happens is the light that's illuminated will reflect off the light, and then it'll be in a concentrated beam. Okay, we see that a lot with satellites. So this thing right here, this is considered the focus, because all the information, or if it's a light, all the light will bounce off of the disk and then all end up in this one central location called a focus. Okay, so that is our focus, and then our directrix is going to be whatever the distance is from our vertex to the focus. Our directrix will also be on the flip side of our vertex. Okay, so whatever the distance is there, that would then be our directrix. Okay, so we're going to talk a little bit more about that in the next coming slides. Okay, so let's say that we have an equation that looks like this. All right, we know that's going to be opening up. Okay, your focal diameter is going to be the distance from your directrix all the way up to your focus. Okay, so I'm just going to put these down here, both of them. Okay, this is just for fun facts. It's really, we just need to jump right in and do some problems to kind of get through this. So watch this. Once you graph your parabola, okay, there's going to be a distance that goes from your vertex up to your focus, and that distance will be the value of C. Okay, now the distance going down to the directrix, that will also be C. Okay, so we have this is C, so this is C, so that means the total distance would be C plus C, which is 2C. Okay, do you see? All right, so now if we have parabolas that are like that, it's the same type of thing. The only difference really between these things is that this is a horizontal line, this directrix, so it's a y equals equation. This is a y equals equation. This is a y equals equation. Down here, this is an x equals equation because it's vertical. All right, so let's try a couple. So check this out. It says, which equation represents a parabola with a vertex at the origin and a focus at -5, 0? All right, so this is what I'm going to do. I know that the vertex is at 0, 0. Okay, it says the vertex is at the origin, and it tells me that the focus is back here. Now, if I remember back from a couple slides ago, I know that when it comes to, or is that little thing? I know that when it comes to my parabolas, I can have a happy face, a sad face, I can have a C or a backward C. Okay, so here, if the vertex is right there, and the focus is always the thing that's in the middle, right? The focus is always in the middle. Which parabola does it have to be in order for this to work? So the vertex is here, and the focus is there. Okay, remember the vertex is right here on your parabola. So which one does it have to be? Okay, good. So it has to be this guy right here. Now, since these two are going to be the y equals x squared equations, I know that this one has to be an x equals y squared equation. So looking up here, I know that I can cancel out a. I could also cancel out c. Okay, and so now I'm looking at both of these. Okay, so since this one is a backward c, I know that it has to be a negative y term. So the best choice here would be D. All right, do you guys understand? Good. Let's move on. Okay, last example here, and then I've got some practice problems if you guys want to give it a shot. So it says identify the focus and the directrix of the graph of this equation. All right, so let's analyze this real quick and try to get our bearing here. So it's y equals, and then the x is squared. So that means that it's going to be either a happy face parabola or it's going to be a sad face parabola. So which one is this going to be since the x is squared? And we've got a negative in front here. Okay, good. So we're looking at this equation right here. Okay, so we know that wherever this parabola is, okay, from the vertex we'll have a focus that's right here, and then we're going to have a directrix that's going to be a y equals equation that's going to be the same distance from the vertex up as it is to the vertex to the focus. Okay, now there was a formula that we had, which was absolute value of A equals 1 over 4C. So if we know the A value, we could figure out what the C value is, which is the distance. Remember, this is the C value going to your directrix and your focus. Okay, all right, so I see that this is my A term right here. So if A is negative 1/16, so I'm going to take the absolute value of that, so that'll be 1 over 16. Equals, I'm going to bring this part down, so that's 1 over 4c. Okay, and looking at this equation, we can almost just kind of do it in our head. 4 times what would give me 16? So then my c value would be 4. Okay, so if I know that the c value is 4, let's kind of now analyze where this equation is going to be. Now this particular parabola doesn't have any other like x term or a coefficient, or I'm sorry, a constant term like a 1 or something. So that means that this one will have a vertex right there at the origin. So if the vertex is at the origin, and we know that it's going to be a sad face parabola, say it's just going down like this, I don't know what it's going to look like, okay? But I know that the focus is going to be 4 units away from here, okay? And if it's like this, my focus is going to be down here. So taking just from the vertex, I'm going to go down 1, 2, 3, 4, and I know my focus is going to be right there. So I could say my focus is going to be the ordered pair 0, negative 4. Okay, that's my focus. All right, so we just did that one. Check. Okay, now the directrix is going to be a linear equation. Remember, it's going to be a y equals equation. So the directrix is going to be a y equals equation. I got to figure out where it's at. So it's going to be 4 units away in the opposite direction. So this is at 4 as well, so my directrix is going to be a horizontal line that goes like this. So y equals 4, and that's how you do that. Okay, so kind of basic. So I've got some example questions that I'll show you. You guys could try it yourself, and then hopefully we can get some gains here. Okay, so here's a couple questions. Go ahead and pause it and give it a shot. And then in a second, I'll show the answers, and you can check to see if your understanding is where you want it to be. All right, well, have a good one, and we'll see you next time.